Alright, so welcome back to the next tutorial in this series. Today we're going to be talking about moving objects, obstacles, whether it be spinning death blades for death runs, or moving platforms, rising elevators, etc., etc. Even things like moving spinning droppers. Or you could stick with the basics and have working elevators, opening doors, custom drawbridges, etc., etc. All of it can be done pretty much the same way. So first things first, you're going to go to your Verse Explorer. You can right click on your death run, add new verse file, and normally I would just call it prop manager, but I already have a prop manager in this one, so we'll just go with prop demo. If I can spell. Alright, with that created, let's go ahead and open verse. Okay, so I'm going to try to have it as zoomed in here as I can to make sure it's easy for everybody to read because I don't have the best recording set up. So let's start with how to rotate a prop. Make things spin, turn, rotating a drawbridge up and down, anything that's going to cause it to pivot. So we'll create our rotate prop function here. And we're wanting it to rotate a prop, so that is what you're going to be putting into it. So it's a prop of type creative prop. Oop. Let me comment this out for a sec. I can't do that. Let me just put a block in here for now so we can pull up the actual creative prop. So prop by default has various things you can do. You can dispose of it, set material, show, hide, etc. But that's not what we're wanting to do. We're wanting to manipulate its properties. Excuse me. But we're not wanting to use any of the default functions. We're wanting to actually manipulate its properties, its position, its rotation. So first we have to get those. So we want the object's transform, and we're going to set that equal to the prop that we created dot get transform, which is already a default function in there. You won't have to create that on your own. And all that does is it gets the current transformation of the prop and it creates a new variable we can actually work with. Now, same thing for the position. We need to get the object's position so that we can work with it. So now that we have the transform of the object, the transform is both the rotation and the position within the map. Which is why we had to create this first. That way we have something we can actually work with. So the position is going to be the transform that we just created dot translation, which is its X, Y, and Z coordinates is what the translation is. Oop, I misspelled transform. Now we also want to get the rotation of the object. Exact same thing we just did. Like I said, the rotation and the translation are both properties of its transform. So transform dot rotation is going to be our rotation that we're working with. Okay, so now that you've got the current position and rotation of the item, we need to define where we're moving it to, which will be the new rotation. Again, if I could spell, it would help. All right, so it'll be our previous rotation. And then we can apply one of three things. You've got to apply pitch, roll, and yaw. And all that is it's spinning around the different axes. You've got spin it around the X, spin it around the Y, spin it around the Z. For this example, let's do roll. And we're just going to have it spin 90 degrees like you would use if you had a drawbridge dropping down or a door swinging open. It's just a pretty standard one to go with. So now that we've got the new rotation defined, we have to actually move it from the old position to the new position. And to do that, we're going to take the prop that we're working with, and then you can either move it or teleport it. If you teleport it, it's just going to happen instantly. It'll suddenly be in its new position. You won't see anything happen, but we want to actually watch it open. So we're going to use move to instead of teleport to. I'm so used to putting that semicolon in there. So we're going to be moving it to a new position and rotation, but we don't need a new position. It's going to stay where it's at since we're just spinning it. So the position's going to stay the same, so we can just use the initial position. However, we are using a new rotation. And then for the last thing, we have to define how long it's going to take to get there. Since the demo, we'll just use 3 seconds. That's a bit slower than what you would normally do to have a door open. But you'll be able to see it better in the demo. All right, so since we still need a way to start this event, so since it's just a demo, we'll just add an editable. You could have add a button, you could add a trigger, mutator zone, spawner, teleporter, on begin, anything you want, but you need something to start this function. So we're just going to add a button. So demo button of type, it is a button device. And since we're bringing in a prop from the game, we also have to include that here. We'll just call it moving prop. And it is a creative prop. Okay. So when this all starts, we're going to listen for the demo button we just created. Anytime it is interacted with, so that is an interacted with event, we're going to subscribe to it, which means we're listening to those events. So all this is the button we just created. Anytime somebody interacts with it, we're going to listen to that interaction so that we know who did it, because sometimes it will require special things for to only affect the person who interacted with it. That won't matter right now, but you do still have to subscribe. That way you know who clicked it. And anytime it's clicked, we're going to rotate the prop. But wait a minute, we have an error here. Why is that? Well, again, it runs on threads. So it's going to try and do this, but it can't do that because the thread it's trying to do requires you to suspend, which you can't do in this context. So we're going to have to create anytime you have something that's suspended or runs on its own thread, you have to spawn it. So we're going to have to create a separate function to spawn it. So we'll just call this start spinner. Now, again, like I said, we have to be able to listen to who did it. So anytime you're using a button, it does require you to identify who did it. So it has to be an agent included with that. We'll just call it an A. And like I said, you will have to spawn said function since it is a suspended function. So we will spawn it. Rotate prop. And we are what did we call it? Moving prop. Oop, wrong button. So anytime we call this function start spinner, it's going to automatically rotate the prop we created. And we want this to be called anytime somebody clicks that button. Hopefully none of this is zoomed in too far that it gives anybody a headache or anything, but I have seen complaints on multiple other videos about it being too small, so I'm going to try and keep it as zoomed in as possible. All right, so now in theory, this should be all we need is these couple lines of code to make an object spin anytime we click that button. So we're going to go back to our Unreal Engine now. First, build verse code. That way it compiles the code we just created. You're going to look for your device for your class, for your verse file you just created, which prop demo is what we called it. And you'll see down here, since we created two editables in the code, it's going to require us to actually assign those editables in the game. So first we need a button. Oops, I'm losing my mind. All right, so here's our button device we're going to use. Turn it around. And then we just need a prop that we want to spin. Let's just keep it simple. There's a bunch of like steel beams we can use. Purple looks nice. And we'll just call you Demo Spinner. All right, so these are the button and the prop we're going to use. So we just assign them. Our demo button is the button we just created. And then the moving prop that we're going to use is the demo beam or demo spinner we just created. All right, so if everything was hooked up right, all we have to do is click this button and then that should rotate 90 degrees. Click, and there it goes. So over the course of 3 seconds, it did a 90-degree rotation. We click it again. It'll rotate another 90 degrees. Simple enough. All right, so what if we don't want it to rotate, we want it to move? Well, I'm just going to go ahead and copy and paste this whole thing here real quick because it's very similar. Oop, it'd help if I actually hit the right button. Except instead of rotating the prop, we're wanting to move the prop. So we'll just call it move prop. And instead of having a new rotation, we're going to have a new position. So we need a vector 3. All this is because the position does have 3 coordinates, your x coordinate, y coordinate, z coordinate. So we need a vector 3 here for each. Now, what are we moving? Do we want it to move across the x-axis, the y-axis, or the z-axis? So just for this, we'll just have it move across the z-axis. So our x is going to stay the same. So x position is going to be our previous position. And same thing for our y. Be our original position of a dot y. But our z is going to be our original position dot z. However, we want to make it go up by, I don't know, let's say 1,000 units. Oop, left out a 0 there. And then we're not rotating it, so we can use, it's just going to be our original rotation on that. However, our position is going to be our new position that we just created. And so we have more time to observe it. Let's make it 5 seconds instead of 3 seconds. Now, just like before, since it does happen over time, it is a suspended function, it will have to be spawned. Normally you would split it up, have different buttons to do different things or different triggers, but just for the demo, we're just going to have it all connected to the same button. So we'll just go ahead and put it in here with our start spinner function. So in addition to spawning the rotations, it's also going to spawn our moving prop here. And we will need a second prop for it to move. So we'll just copy this, call it moving prop 2. All right. So now everything is set up. When we click that button, it'll just move the prop that we're going to add in. So let's go back to the editor. We'll just duplicate you. Oh, forgot to build the code. So build verse code. And now that third editable we just created should show up on here. Unknown identifier position. So apparently I have misspelled position. Yep. Oh, oops. I forgot to actually define that. So my bad. I was wondering why I was getting an error on that. All right, now let's build the verse code. And it should pop up. Yep. So this second one should now move up when we click the button. So let's go ahead and push verse changes. So back in the game, we click this button. That one should rotate 90 degrees, and that one should go up 1,000 units. Yep. Goodbye, beam. All right. So simple enough. Now this is all well and good if you want just something to move one time, an elevator, a door, etc., etc. But for a lot of maps, you do want things to just keep moving. So how do we accomplish that? Well, the simplest way is with a loop. So let's go ahead and create a new function. Let's do the rotating one first. We'll just call it spinning, just to keep it simple. And we're going to be spinning a prop again. And we already know it's going to be looping through the function, so we'll just go ahead and add the spins. A lot of what you'll see in the tutorials is on destination reached, which is just whenever it gets from its original position to its new position, it triggers it automatically again, which does create an infinite cycle. Now that's fine for a short-term use, but I have had issues. It could just be me, but I have had issues that after 45, 50 cycles, it starts having bugs. All right, so let's do our loop. And rotate prop. With the prop we submitted here. So instead, go ahead and switch this up here. We are now using the spinning function. And the prop we're using is going to be our first one. All right, so simple enough. An infinite loop. So let's go test that real quick. Back to the editor. All right, and so it's infinitely looping. Every time the function finishes, the loop just calls it again. So you have an infinite spin. Now, what about the moving prop? We don't want to just keep going up infinitely. That's pointless. So if you want a moving platform for a death run, you can have it go up and then back down and then up and then back down. So let's go ahead and copy this function. So we'll call this move prop up and call this one move prop down. And instead of going up 1,000 units, it's going to come down 1,000 units. So minus. And that's a bit high, actually. Let's just go ahead and change them to 500. Now, same thing. We're going to need a function to loop it in. Elevated platforms, we'll just call it rising. And it's going to loop. It's going to move them up. And it is the prop that is given. And then after it moves it up, it's going to move it down. And then it'll loop back through it, go up and then down, and then up and then down. Oh, wow, I messed that up. Okay. Back to the editor, build verse code, push verse changes. All right, click our button, and it goes up, and it comes down. And it goes up, and it just will keep doing that forever. Now, there are a couple things we do have to worry about on this, though. One is memory usage and processing. Infinite loops are never a good thing, because if you've got dozens or even hundreds of things moving in your map at the same time, that's going to put so much strain on people's systems, and people on lower end systems like mobile or Switch probably couldn't even play the map. And another issue is range. Everything is spatially loaded in this game. So if you get too far away, it's going to stop giving as much processing power. Example on that is one of the earlier maps I did with moving obstacles was fairly long, and by the starting point of the map was out of render distance of where some of the props were moving. So since they were running infinitely from the time the map started, by the time you got to it, they had started glitching out. So best practice is to not have the props move until you actually need them to. Like right here in the demo I gave at the start of the game, these right here are those spinning blades you saw, but they're not going to start moving until somebody enters that area. Now there's different ways you could do that. You could find the character's position and track them and how far they are and all that. And that's probably would be the correct way to do it, but there's a lot simpler ways. You could do a mutator zone, or just whenever somebody enters the red area, it would start them moving, or you could have them step on a trigger. In my case, since each of the areas are entered through teleports, I just have it set up on a teleport. So those props will not move until the first person enters the teleport into that area. So how are we going to manage that in game? Go back to our verse code. So, I mean, again, the button's going to be fine for this example here. But one of the benefits to having it in a loop instead of using like on destination reached, which is what a lot of the other demo videos out there call for, is instead of having a loop, it's any tracks when it reaches the destination and then just goes it again. But since we have it set up in a loop, we can also check if they're in the area with an if statement. So we'll go ahead and get that set up real quick. Where do I want to put this? We'll just put it up here. So I'm going to have a variable. We'll call it is in area. And type int. And we'll start it at 0. And even once you click this button, it's going to start moving. It's going to start the loop. It's not necessarily going to start the prop. It's just going to start the loop. So we're just going to check if your map's only going to have one person, you can do this with a logic instead of an int and just true or false, are they in the area? But since this is a map that will be played by multiple people, what I'm going to do is just keep it as a count. How many people are in that area? And anytime it's not 0, the props will be moving. So if the number of people in the area is greater than 0, then we will rotate the prop. If it's else, so if there is only 0, if there is nobody in the area, we're going to break out of the loop to save memory and processing power in the game and keep there from being bugs. Again, infinite loops are never a good thing if you always need to have something that would cause it to break out of the loop. In this case, we want it to stop moving the props if nobody's there using those props. So same thing down here. Okay. And then we need to have the function that actually raises it. So again, on the actual map, I've used teleport. Every time somebody comes through that teleport, it increases the people in the area by 1. And then when they leave the other side, it's going to decrease the people in the area by 1. Now, obviously, that's not perfect. I mean, if someone just straight up leaves the game while in that, it's going to have them permanently running. But in most cases, this will work. I mean, like I said, this is designed to be a beginner course. I'm not going to go in depth into checking number of people in the maps, checking where they were when they left, and all that kind of stuff. Just as simple. We're going to use buttons, teleports, etc. So we'll go ahead and use the demo button we've got here. So we want to increase and decrease function for that. And since it's a button, we do have to listen for an agent, even if we're not using it. So we're going to set the number of people in the area plus 1. And we're going to have a decrease. Is going to set it minus equal to 1. Whoop. All right. And so when that start button as it is interacted with, it will add a person into the area. And we're also going to need something that causes people to leave the area. We'll just create a second button for this for now. Like I said, you could use teleports, etc., whatever. I'm sure y'all are tired of hearing me repeat myself on that, but I mean, it is what it is. You need some kind of device to track when people enter the area, some kind of device to track when people leave the area. And so when the second button is clicked, it's going to reduce the people in the area, indicating someone has left it. Okay, so still in the code. So every time we increase the amount of people in the zone, we need to do the spinner. So start spinner. All right. So every time we click the start button, it's going to increase the number of people in the zone and then start the spinner function. But the issue with that is it's going to keep trying to start. We only want it to do it the first time, when the first person enters the zone. So if is in area equals 1, then we will do that. Else we do nothing. So when the second, third, fourth person enter the area, it's not going to keep trying to restart the loop. Cut down on some bugs that way. All right, so let's go back to the editor and take a look. Build verse code. And push first changes. All right, so again, this is just for demo. If it was in the actual map, how this would be considered is nothing's moving because nobody is in that area. Every time we click the enter button, or every time someone enters the area, if they're it's going to increase the number of people within range. If that is the first person entering the area going from 0 to 1, it would then start the movement. After that, it would do nothing except increase the count. Decrease would be the same. Every time someone leaves the area, it would reduce the number of people within range, and then when that hits 0, it would stop moving. So let's try it. So first person enters the area, click, it starts moving. So now there is technically one person within range of these, so they're going to keep moving until that hits 0 again. So click, there should now be 2 people within range. Nothing changed. And one more time, 3. So there are now 3 people within range of those. So for those to stop moving would require 3 people to leave the area. So click, 1 person left, click, 2 people left, and click. So when the 3rd person has left the area, the loop will stop. So that stopped moving instantly because it was at the end. When this one makes it all the way back down, it should stop as well. Yep. So it has returned to its original position. And everything's good. So that keeps you from having bugs whenever things are out of range or wasting memory on moving props when nobody is in the area where that prop is running. It's just a good practice if you're going to have things moving infinitely because, infinite loops are very bad for games. All right, so one last thing to talk about on here is, yes, we can now move the props any way we want. We can have them spin, move up, down, left, sideways. If you want to move it at an angle, you can have it move up and right at the same time, etc., etc. It's just basic math at that point. But there are a lot of things we can't move. For instance, the bumper devices here, which I'm using as damage blades, do not currently have a way to directly bind them in the code. And even if it did, you don't want to have to write the same movement code over and over and over, once for a prop, once for a bumper, once for this device, once for that device. It's so much easier just to write it one time for a prop and then attach the other stuff to that prop. So, I mean, that's literally it, is attaching. So let's go back to the editor. So we were already talking about bumpers, so we'll just go ahead and keep using the bumpers. And make that a bit longer and skinnier, like something you would want to dodge. Right now I want to change the way that rotates real quick just to make it easier to see in this example. So instead of applying a roll to it, let's apply a pitch. That way to rotate the other direction. Oops. And now this right here, we're going to attach to our demo spinner. So you just right click on it, attach to, and demo spinner. And now this is going to rotate around that as it rotates. So this is going to be its pivot point. So as this spins, this is going to spin around it with that as the center. And you can just copy and make more. And since they are attached to this as the parent, when you move this, both of them are going to move with it. So we're going to go ahead and push changes. Alright, so back in the game, they have entered the zone, and now it is moving with it. Again, you can change the speed, the angle, anything you want with it. And it's not just limited to bumpers. Just to keep things simple, you can attach any device, any object you want to this prop. That way you can just use that one prop mover function for everything. You don't have to create a new function to move the bumper, a new function to move a platform, a new function to move a doorway. You can just use this one prop mover function and that's it. And now if you don't want the prop to be seen in the game, you can either do like I did here and just hide the beam that they're spinning around outside the walls, or like I talked about in my previous custom materials video, you can make a transparent material and just turn it invisible, and then they won't be able to see it regardless. But the main thing is just making sure you're managing your players, because again, there's no sense in having these things running when there's nobody around to see them. Infinite loops are always bad for your game, so you have to have some way to check when people are in range. Like I said, this is just beginner's basics. That's why I used a teleport between each level. That way, just like with the buttons, every time somebody interacts with that teleport, it increases the count and yada, yada, yada. But you can set it up however is easiest for you, just so long as you make sure that the unnecessary functions are not running when nobody's around. And so that's going to be it for this tutorial. I'll put the code for this map on screen and in comments as always. That way y'all can take a look if anybody wants to see how these functions actually look in game. And I'll be back for the next one, hopefully next week, maybe 2 weeks. I'm not sure how busy things are going to be at work at the moment. But yeah, hopefully this helps some people out. And if y'all have any questions, throw them in the comments. And once the series is over, I'll go back and try to answer any questions people have. Y'all have a good one.